So guys, this is our workbench. Here you can see the toolbox. Here we select static structural. If it's done, we will put engineering data. Engineering data, we will select the material and the Young's modulus and other properties of the material which we have to put in our design. So just right click on it and add it. Our interface is open. Here you can see there is a material already enabled, structural steel. But if we have a different structure or different material, we use different materials and we can edit here. Just click on it and type stainless steel, enter. Here you can see our new material is created, but you are seeing here that is a question mark here. This question mark demonstrate us that we don't put their properties, so we will put isotropic properties. So we click on isotropic properties here. We will add, here we will add the Young's modulus. Here we can see here this is Pascal. You can change according to your problem statement. I am changing here this is GPA and I will put the value 193 GPA. 193 GPA. You can change accordingly. The poison ratio is 0.27. Okay, just enter and you can see here the question marks disabled. Here our property and material is created, which Young's modulus 193 gigapascal and poison ratio is 0.27. Now come to the project again, click on it and here check 2D body. We are analyzing a 2D object in 2D demonstration. Okay, now right click on it and open new space claim geometry. Here you can see in the left bottom corner starting space claim means it's utilizing your system and opening space claim. So don't do anything while using ANSYS and make sure you put your PC on charger. Now we have to select a plane to draw our design and then we will get into the model phase. So first we will go design, select this, and if you have to draw in XY plane, then select Z and sketch mode. Here you can see a plane is created on XY plane. Just click on it, plane view. Here you can see XY plane and enabled. Now we have to create, just take a line for type 40 mm in the box. Now for measuring distance, take dimensions and here you can provide it as 6. This is a kind of smart dimension. Here we put the distance between the axis and the line is 6. Now we have to create another line, same another line on this side. So we use mirror, select on which we have to mirror, that is axis, and what we have to mirror, this line. We click on it and here you can see the line is mirrored. Now select 3-point arc, just click 2 point here and give the radius of the circle and the radius is 10. Just enter. Here you can see a 3-point arc created a circle for you which radius is 10. Okay, now another 3-point arc, take, click on it, uh, click on the vertices and now enter 12.5. Here you can see our circles are created. Now just escape to remove the selection and now select here polygon. You can change sides accordingly, whether you need six spaces, 6 edges, 8 edges, 7 edges, according to your need. Now click on it and put the diameter, it's 12. Enter. Here you can see this is created. Now we have to we are making a wrench, so we have to create a gap here to uh, fastening the fastener. So just click line, make a line exactly straight. Okay, this is created. Now another line on this, like this, and we have given that this distance at this distance is 10 mm. So just click on it and put 10 mm. Here you can see this line is 52 10 mm gap between this point and this point. Now we have to trim the extra parts, this part, and this part. Here you can see a ridge like shape is created. Now we have to create a round corner here and here. So just click on right corner. Here you can see that the corner, create round corner, and now click on it and put the value to 0.5, the radius as you need. Here I am also put 2.5. Here you can see our wrench is ready. Wrench is ready in 2D, but now we have to make it 3D to analyze in model space. So just click on it, design, pull. Here you can see there are many options. Click on surface. Uh, Here put 3 mm thickness. Don't pull by this because we are doing 2D analysis, and just we have provided thickness 3 mm, but it's not showing here, so don't worry. This model is generated. Now we have to save. We will go to workbench and save our workbench. Control plus S, and where you want to save, you can save this. I am saving on desktop only, so the name range I am saving. Make sure you have saved your file to move on further process. Now we will go to model and edit. Here you can see the left bottom corner showing starting mechanical, means starting our mechanical window. Now here just wait to import your geometry. Now you can see our geometry is imported here automatically. We have not done nothing done. Now we have to insert method, select the body, apply. Now we have to choose it automatic prime mesh. Now click on insert. Again sizing, we have to define the size of the mesh. So apply and change the default size by 0.2 mm. Now just right click on mesh, generate mesh. Here you can see overall progress generating mesh. A fine mesh is created on our wrench, you can see here. Now we have to analyze this on different boundary conditions. First we will put the boundary conditions. So right click on static structure, insert, and fix support. And here you get fix support, and we will providing fix support to this. Select vertex type selection. Here you can see it's vertex type selection. Now edge type selection. Simply for more than one edges, you have to create. You have to select one, then control and click on the edges, whatever you want to select. Here we have selected all the 6 edges. Now six edges are selected. We have provided fixed support, and now we are providing pressure to the ridge. Now again we have to select an edge, so we have selected edge selection, and here we are providing the pressure while using the wrench. And here you can see this is a normal 2, okay, defined by normal 2. Change it to components, okay, and we are providing this pressure in downward direction. So here you can see this is upward direction in y, and downward direction is minus of y. So in minus of y, put value minus 2 megapascal, minus 2. Here you can see all the units are in Newton mm. E6, that is in Pascal. Okay, so we have created this. Now just we have provided the boundary conditions. Now what we want, the result we want to, so we want deformation, total deformation we want, and another one, we want to check the stresses, how stresses are distributed throughout the range. So we will select equivalent one meshes, and here we select. Now just we have to solve it. Before solving, check the mesh is generated or not. If yes, just right click on static structural and solve. And here you can see our model is solved. First we will check total deformation, how deformation varies, how deformation is varies along the range. There here you can see this is the fixed support, so deformation is not occurring here, and the deformation is maximum at this end. Now on equivalent one basis you can see how stresses are distributed. Maximum minimum stresses are here, and maximum stresses are, you can see, at the edge of this circle. I stopping it, then you can see there is a maximum stress generated in our range. So our problem statement is done. We have to find the maximum stress, minimum stress, and deformation occur in the range of this dimension. Here you can see a graph. Here you get the value, all the values. Thank you.